Let's see. So who can tell me, first of all, like, what is a subnet mask? Tell me some things about the subnet mask. And go ahead and do it verbally, and or some of you, if you don't have access, you could pop it in to the chat box. And again, Robert and Spencer, if you could just pay attention to the chat box so that I don't have to look at it while I'm here. So let's talk about the subnet mask. What can you tell me about the subnet mask?
For me, is what is the biggest parameters of the subnetting, of the IP subnetting for the VLAN, for the network VLAN. So depending on the octets will remain exactly for each host.
Yeah, we can use the octets to help us with the hosts. What else?
Okay. Sorry, there's some comments in there that says determines what where the area of the IP address is, a range of IP addresses.
Yeah.
It breaks up networks into a range of addresses through classes, and someone put like a zip code.
Yeah.
So.
Exactly right. Exactly right. So an IP address has two components, okay? The network portion and the host portion. Now, when we just look at an IP address, we can't really tell what the network portion is and what the host portion is. So like, I'm going to show you if I pull up my IP config, like if I go in here to the command prompt and I do an IP config /all, like I can see my IP address is right here, okay? But it doesn't tell me what network I belong to, okay? That's what the subnet mask does. A subnet mask tells us what network I belong to. And I like the analogy, Adam, I think it was you that said like the zip code. So the zip code kind of like for our houses tells us like what area we live in, right? Or what post office our mail comes to. So a subnet mask can be considered to be something similar to a zip code. So keep in mind, like a zip code isn't a real address, right? It's not an address. A zip code is an indicator of where my mail belongs. It's the same with a subnet mask. A subnet mask isn't actually an IP address. Even though it looks like an IP address, it's really more of an indicator of a network and the host portion of my IP address. And today's conversation about subnet mask is more just the semantics of a subnet mask and the formatting of a subnet mask and how to figure out a subnet mask. Whereas on Thursday, we start to learn how to figure out how to use the subnet mask, right? So the subnet mask separates our IP address into the network and the host portion, because remember, an IP address is made up of a network portion, kind of like the zip code, and a host portion, which is like every one of us, we might live in the same zip code, but we have our own unique address. So like I live in the 85018 zip code, but I have one address, my neighbor has a different address, my neighbor's neighbor has a different address, but we all share a zip code. It's the same goes with a network. So I want you to think about our classroom. So in the classroom, we would all have the same subnet mask, but we would all have a different unique IP address. We can't share IP addresses. Just like my address cannot be exactly the same as my next door neighbor's address, okay? So again, I like to think of the subnet mask more as an indicator because we're using the ones and the zeros to help us determine or indicate what part of my unique IP address is the network and what part of my unique IP address is the host, okay? So a subnet mask isn't really an IP address. Think of it as an indicator, okay? So next question, if someone could answer, is what is the significance about the formatting of the subnet mask? So how is it formatted? We know it's in binary, right, like everything else, because that's the language of computers. But what do you notice about it? What's significant about it?
The on and off from left to right are consistent in that,
yes.
So the on switches continue until they reach 0 and then they don't turn on.
Yes. Yeah, who is that talking?
Michael.
Michael, exactly right. So the ones are all continuous on the left side, and once it turns off, it stays off, right? Whereas with an IP address, we see flip-flopping, right? We see 11001011. However, with a subnet mask, it's ones and zeros, and they're all going to be consecutive, and all the zeros are consecutive. There's no flip-flopping, right? So where would I find a subnet mask? Where might I see a subnet mask?
IP configuration.
Yeah, on the IP configuration, right? Just like what I had shown you before. Now, truth be told, anything that gets an IP address also needs a subnet mask. Okay, so not just on the IP config, so not just my host device, but routers would need a subnet mask. If I set up an IP address on my switch, it needs to know what the subnet mask is, okay? So on my IP config, so here if we take a look, this is actually what I had just pulled up. So I can see right here, here's my IPv4 address and here's my subnet mask. So if we think about this, remember the subnet mask is an indicator. The ones in a subnet mask indicate network bits. So that is the network. And what I do is wherever there's a 1 that correlates with my IPv4 address, I know that that part of my IPv4 address is a network. Wherever the zeros are, that is the unique host portion. So ones represent network bits. Zeros represent host bits. So networks and hosts. So all it does is it indicates what part of my IPv4 address is the network, what part of my IPv4 address is the host. Are we good on that?
Yes.
Awesome. Okay, so the subnet mask gets combined with my IP address to determine what the network address is. Okay, and that's what we're doing next week. Or Thursday, not next week, Thursday. It says we're doing that on Thursday. Okay, so the math is the same for a subnet mask. We write a subnet mask in binary. So we already, if I'm looking at this 255, how do I write that in binary? We've already figured that one out. So how do I write that in binary? Pop it in the box. Adam, all ones, yep. Perfect, David, yes. So, and then if I needed to convert it from binary to decimal, what if I had 7 ones and a 0? What would that value be? 7 ones and a 0. 254, 254, exactly, okay? So in some ways, a subnet mask is a little bit easier because we're not flip-flopping the bits on and off. They're either all on consecutively, and once they get turned off, they're all off consecutively, okay? Good on that? So what do the ones indicate and what do the zeros indicate?
Ones are network bits and zeros are host bits.
Yes, yes, exactly. Sorry, I gotta turn my fan on, I'm overheating. Okay, so if the math is the same, how would I write 255.255.254.0 in binary? So everybody pop it up into the box, into the chat box. How do you write, and send it to Robert and Spencer. Send it to Robert and Spencer. Or the panelists. Then it comes to me too, the panelists. So go ahead and pop it in there.
2 correct responses, 4 correct.
Perfect, that looks good. Yeah, I see tons of correct answers. Okay, now how about 255.255.128.0? How do I write that one?
Mm-hmm.
That looks good, that looks good. Keep it coming. Then let's do the last one, 255.240.0.0. 255.240.0.0. Looks good, right? Awesome. So here are answers, right? Check my work too, make sure I got it right. So again, what do we notice? Everything's consecutive, and then it turns off, okay? So these ones represent what? These ones represent what types of bits?
Network bits.
Network bits. And how about these zeros?
Host bits.
Host bits. Exactly right, exactly right. All right, so let's see. Now let's go the other direction. So everybody pop in the chat box, let's do the first one. So if I've got the first octet on, the second octet on, then 5 bits on, and then the fourth octet off, what is my decimal equivalent? What is my decimal equivalent? Let's see. William, recalculate yours. So after you do the first one, everybody just do that first one. Hi, Tanner. I just saw you in there. There you go. Got it. Okay, now let's do the second one. Let's do the second one. I can tell some of you guys have been practicing your binary. Do the second one. This guy right here. We get a couple more answers. Not quite, Jose. Recalculate that one. Looks good. I got lots of right answers. So let's see here. Let's do the last one. So remember, you've got to add up the positional values, right? We've got to figure out, if you don't have those positional values memorized yet, you got to figure those out. And you could just write them out, right? 128, 64, 32, 16, 8, 4, 2, 1. Or 1, 2, 4, 8, 16, 32, 64, 128. Okay, that looks good. So I think you guys got the hang of it. That's good. Okay. that look right? Check my math. Okay, so there is another way to represent a subnet mask. What is that called? What is the other way that I could represent a subnet mask? So the easiest way that we've talked about so far is decimal, right? 255.255.255.0. That's much easier than saying 11111111 dot 11111111 dot 11000000, right? So, okay, I see a couple answers in there that are right, a couple good guesses. Okay. Get an answer from everybody. Good job, Hollis, yes. Hey, can somebody go ahead and call it out? What is the other way?
Notation.
Yeah, prefix length, right? So a nice shorthand way to write a subnet mask is with a prefix length, okay? Now with a prefix length, what are we doing? How do we come up with the prefix length? Somebody answer verbally.
It's the numbers of one that we have in the subnet mask. For example,
right.
5, it will be 11111.
And then everything else would be zeros. Yeah. So because we end up writing subnet masks all the time, we just have an abbreviated way to do that, and that is we just count up the number of network bits, or the ones, and we call it a slash notation or a prefix length, and we just write /25 or /24, just however many ones there are, right? So the ones represent what?
Network bits.
Network bits. So the prefix length is an indication of the number of network bits, okay? And the zeros represent?
Host bits.
Host bits, exactly right. So let's say I have a /24, okay? So I have a /24. So if I have a /24, what would my subnet mask be in decimal?
55.255.255.0.
Exactly, because I know that I have 25 ones, right? And how many ones are in each octet?
8.
8, right? So I know I've got 8 plus 8 more, that's 16, plus 8 more, that's 24, okay? Now, if I know that I have 24 network bits, how many host bits are left over?
8.
8, right? So I could actually, I know that there's 32 bits in an IPv4 address, so I could do the math, right? I could figure it out like that, right? Or I could think of it in terms of the octets, right? So there's a couple different ways. So as long as you know what the network bits are, you can always figure out what the host bits are. So how about a /16? How many network bits do I have? How many network bits do I have? Pop it up. There we go. Keep going. Looks good. How many host bits do I have? How many host bits? Yeah, I'd have 16. Because if I have 16 network bits, I need to have a total of 32 bits in my IPv4 address. So if I have 16 network, I must have 16 hosts. Okay? All right. So what is the prefix length of this very first one? Everybody, what's the prefix length of this one? What is the prefix length?
24.
24, exactly. Because what do? I just count up the ones. So I know that there's 8 bits in an octet. So there's 8, 16, 24. So my slash notation or my prefix length is 24. Okay, how about this guy? That looks good, yeah. Okay, how about the last one?
8.
8. Okay, looks good. Check my work. Right, looks good. Okay, so something I want you to start thinking about, because we're going to start thinking of things in terms of the octets and their boundaries. So whenever you have something on a /24, a /16, or a /8, we refer to that as a boundary or an octet boundary. So we can see here that a /24 is on an octet boundary because it divides right between the octet of 3 and 4, right? And then I've got another octet boundary. The /16 is an octet boundary between octet 2 and 3. And then I've got an octet boundary between 1 and 2. So this can also be thought of as something called classful. Okay, so it's classful. It falls on a known class or a classification. Make sure you're taking notes if you're not already. All right, so let's see here. Let's review what are the octets. So what octet is this guy over here? The first one, right? This is octet number 1. And then we just go down. We have this is octet number 2, 3, and 4. Right? Does it make sense? And you're going to start to see next week or Thursday and next week why knowing what octet these are will be real helpful. Okay. So what do we know about the positional values as it relates to the octets? What do we know about the positional values as it relates to the octets?
The single octet position values is 128, 64, 32, 16, 8, 4, 2, 1.
Yeah, and is it the same for every octet, or is it octet?
They reset every octet.
Yes, exactly. They reset every octet. They repeat, right? So here's our octets. Here's our first octet, our second octet, third, and fourth. And notice the positional values repeat. 1, 2, 4, 8, 16, 32, 64, 128. They repeat. That's why with a subnet mask, say of 255, 25500, why I can have 255 twice. Because I just add up, they repeat in each octet, right? They repeat. You know what I mean, right? The rest of these are all zeros. Okay, does that make sense? Yes, Andrea. Okay. All right, so let's try these. What is the prefix length of this first one?
23.
23. All right, does everybody get 23? Okay, pop in the chat box. How about this one?
17.
Exactly. And the third one. Good job. I see lots of 12s, yes. Okay, now, do any of these divide on the octet boundary? Nope, none of them do, right? None of them do. Because we can see this one divides right here, this one divides right here, this one divides right here. So, when they divide on the octet boundary, what do we call that? Classful, right? When it's on the octet boundary, it's classful. Now, if it's not on the octet boundary, anybody want to make a guess what we call it? Yeah. I see a couple right answers. So when it's not on the octet boundary, we call it classless. They're classless. They're classless, okay? Again, this is going to come back to us. All right, now here's the next thing that I want you, unclassy. Unclassy, that's actually very good. It's classless, classless. Okay, so here's the next thing that I want you to start to notice, okay? I want you to start to notice where the last network bit is. I want you to notice what octet the last network bit is in. So for this first one, what octet is the last network bit in? So here's the last network bit right there. What octet is that? Right, it's 3. 3, very good. Again, this is going to become super important as we move through. So if we already start practicing, oh, that's in the 3rd octet, blah, 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 blah. It'll mean something to us. All right, how about this one? Last network bit. What octet are we in? We're still in the 3rd. Now, what if you had a prefix length and you did not have the binary? Could you still figure out what octet you're in? Yeah. So what octet is this one in? The 2nd. How about a /28? What octet is a /28 in? /28. 4th, okay? How about a /9? 2nd, exactly. Now, we'll pretty much never have less than that. Like you won't have a /7 or a /6. Like I've never ever seen anything like that. So you're never going to have anything like that when it comes to this first octet, okay? All right, so what is the binary, or what is the prefix length for this one? 255, 255, 248. So prefix length for 255, 255, 248.0, this one. When in doubt, bid it out, right? You might need to bid it out. So let me talk about this one for just a second. When I say, when in doubt, bid it out, right? Because sometimes you just need to bid it out. Do I need to actually bid out the 255? What do I know? Whenever I see 255, what do I know right off the bat?
That is an 8.
Yeah, I know right off the bat that there's 8 of them. So I don't necessarily need to bid this one out once I've practiced a little bit and I just know 255 is 8, right? Now what about right here? I've got another 8, so I know that's 16. So in order to save yourself time, just bid out the octet that you need, right? So if I'm going to bid out 248, then I know how to bid out 240 because we've been practicing 240. Now I turn the 8 on and the rest are off. Do I need to bid out the 0? What do I know about that 0 in octet 4? They're all zeros, so I don't really need to bid out the last octet. When I have a 0, they're all zeros. So one shortcut that I'd like you all to practice and to learn is don't bid out things that you don't need to bid out. We know that when we see 255, that's 11111111. It's 8 bits. It's 8, right? When I see 0, I know that that's 00000000. I don't need to bid it out. So I just look for the octet that I'm not sure about, and I bid that one out. Okay, does that make sense? Does that help a little? Give me a yes. Thank you. Okay, let's do the next one. 255, 255, 192. What is the prefix length? So this little guy, what's the prefix length? So I know right off the bat I've got 8 plus 8. Excellent. I see a lot of right answers. Good job. Okay, let's do the third one. So I know right off the bat 255 is 8, so I might need to bid out 252, right? There's 240, 248 plus 4, 252. I turn everything else off, all the zeros. I know those are zeros, right? Everybody get that one? So that's a what? /14, right? That's a /14. Oh, look, I have this wrong. What's the right answer for this one? So see, what octet am I in right here? On this first one, what octet am I in? I'm in the 4th, but look, I need to be in the 3rd, right? So what's my slash notation for this bad boy? /21. Let me fix this right now. /21, there we go. Okay. All right, so now what are we going to do? We're going to take these values and we're going to tell me what the decimal is. So what's the subnet mask for a /9? What is the subnet mask for a /9? Excellent, excellent. Okay, /28. What is the subnet mask in decimal for a /28? Looks good. Couple more. And the last one. The last one. Keep going. Right? Okay, up here, which one of these, which ones are classful? Which ones are classful? Which ones are classful up here? I see a couple right answers. So classful means that they are on the what boundary? They're on the octet boundary. So right here, this is the only one that's on the octet boundary. 255, oh, that's mistype too. Wow, I must have been rushing. 255, here, let me fix that. 255, there we go. Right, so when they're on the octet boundary, they're classful. So all the others are what? All the others are what?
Classless.
Classless. All of the others are classless. Classless is the most common. Unclassy. I kind of like that. I think it's really funny.